Um, Nothing really new. I think I'd like to get ahead.
Okay. Do you have, was today a school holiday or not?
No.
Okay. What kind of stuff are you covering?
We're covering using focus and directrix to find equations of parabolas, but it's really easy.
Okay, we should go over one or two of those because it might not be as easy as it seems. It sounds like you're in conic sections, and they start you out in conic sections on parabolas, and then they go to circles, and then ellipses, and then hyperbolas. Does that sound about right?
I have no clue.
Okay. Well, conic sections are kind of a different breed of animal. The most important part of all of it is to memorize the standard formula. So let's talk about the conic section that you should be absolutely familiar with, which is the parabola. And the equation of that parabola is y equal x squared. Okay?
Hmm.
You've been having this equation for 2 years at least.
Yep.
Well, there's something else about, and in fact, the general formula, the general vertex format for a parabola is actually this. Okay? It's just that one that is centered at the origin where h and k are 0 and a is 1 ends up y equal x squared. You with me?
Hmm.
Okay? Because they're going to make it more complicated for you. In other words, they're going to change this general format. As soon as they start talking about parabolas as conic sections instead of quadratics, they're both. But as a conic section, it shares a certain property that we never talked about when we were talking about quadratics. And that is that there is some point right there that every point on that parabola is the same distance to that point as it is from an imaginary line called the directrix. What I mean by that is that that distance is the same as that distance. This distance is the same as this distance. This distance is the same as this distance. In other words, you always have to draw your line perpendicular to the directrix. But all of those are the same, which is a feature of parabolas that we never really talked about before. It's only when you are examining parabolas as conic sections that they get into this. And it changes the whole general equation also, because we now have some extra stuff that we need to know, which is what is the distance from the vertex to the focus? That's P. What is the distance from the vertex to the directrix? That's also P. And there's only one focus in a parabola. And here's a very interesting part of parabolas is that if you were to put a bulb right there, light bulb, all of its rays would go in all kinds of different directions, right?
Hmm.
But they would all hit the parabola and bounce parallel to this y-axis. In other words, that light bulb would have all of its rays focused so that they all go out vertically from the light bulb. And so if you were to go to examine any flashlight in the world, the cone that surrounds the light bulb is going to be in a parabola shaped, because that makes all of the light go straight out and there's not as much dispersal of the light. So if you want as high energy beam or as bright of a light as you can get, you put the bulb at the focus. And it works the other way around also, where let's say you're trying to receive signals from a star in outer space. Well, you put your receiver right there at the focus, because all of these signals from outer space come in on this path, because they're coming in from many billions of miles away. So basically, they're coming in on a parallel path to that vertical line, and they all, no matter where they hit, they get bounced to the focus. So if you put a little receiver where your focus is supposed to be, you capture all of the rays that come in from outer space from stars and star systems and stuff. So not only are flashlights all built with parabolas, but most all receivers, what do you call them, these like even the Hubble telescope, but any telescope that's on Earth would be shaped like a parabola. Well, how do you shape it like a parabola? You take a parabola and you rotate it about the y-axis to find a solid. And so the solid still looks like a parabola, but if you were to go outside and look on the top of everybody's roof, you'll see an awful lot of people have dishes. They're all parabolas, and they all have a receiver right there.
Mm-hmm.
So they're pointed at the satellites in outer space, and all the rays come in and they all bounce to the receiver. That is a property of parabolas. Probably the most important property of parabolas. Okay, so viewing these quadratics as conic sections turns out to be very valuable in the real world. Now, here's the thing. They use a completely different formula than what I have written up there. The formula they use is this one. Hold on a second. I gotta figure out where the K goes. Open my book. I don't want to make a mistake. Wow, you're in chapter. Of course, it's completely different for looking at a pre-calc book. Yeah, the K is on the other side. Notice that if I take the original and move the K to the other side, it becomes y minus K. Well, that's really what it is. It's 4p times y minus K. And there is no A. The A ends up getting incorporated into the 4p. So this standard vertex format completely changes when you're talking about it as a conic section. Notice that it doesn't completely change. There are some school systems that don't use this. Is this the format you use?
No.
Really? Wow. So the format you must use.
Well, we haven't gotten to that yet, if that's the format we use.
Oh, okay. Well, here's
That's
the
fine.
thing, is that A is equal to 1 over 4p. And notice that if I wanted to use the original format, I would have y minus k equals A times x minus h quantity squared. Well, if I make A equal to 1 over 4p, then that becomes 1 over 4p, which is what A is. And now if I multiply 4p by both sides of the equation, I get the equation that I have check marked. Second one up there. And the value of writing it in conic section format is that P is the most important thing in this parabola. Well, second most important thing. In other words, the most important thing are probably the vertex, which is still h and k, but P gives you the distance to the focus, which by definition also gives you the distance to the directrix. So let me take a real simple example. I'm going to say 4 times y minus k equals x minus h squared, and I'm going to substitute 0 for both of those. So really what I'm going to have is 4y equals x squared. And then the question's going to be, where is P? Okay. Well, first of all, we know it's, if I wanted to, I could write this as y equals 1/4 x squared, right? Well, that means its vertex is still at the origin. But more importantly, where is P? What is P in this case?
This is 0.
No, if 4P equals 4, in other words, if the coefficient of that y term, whatever it is, P must be that coefficient divided by 4. So P would be 1 in this case. Well, what does that mean? It means that that focus is right there at 1, and the directrix is right there at y equal minus 1. The focus and the directrix are always the same distance from the vertex. So wherever that focus ends up, and the distance from the vertex to the focus is P. Okay? Let's go back and do another one. One more, and I know you'll get it. I may have confused you a little bit with that one, but let me write a different one. All right, here we have a parabola whose vertex is at 3, 2, correct? In other words, h is the x-coordinate of the vertex, 2 is the y-coordinate of the vertex.
Mm-hmm.
So if I go to 3, 2, there's the vertex. I know that it opens up because everything's positive. Remember, I need a negative number in front of the x squared term for it to open down. So I know that it opens up. Now the question is, where is P? relative to the vertex. In other words, this distance right here is P. What is that distance?
Um,
Go back to this format. That's the one you got to memorize. We've got the y minus k right there. We got the x minus h over there. So 12 must be equal to 4p, right?
so P is 3.
Yeah. So this distance right there is 3. So if I really wanted the coordinates on P, I would start with the vertex, which is at 2, 3, 3, 2. H coordinate goes first. And I would just go up 3 from there. So the coordinates on the focus is going to be 3, 5. Now, what is the equation of the directrix, and is it below or above the x-axis?
It's below the x-axis.
What's the equation of it?
Y equals -1.
Good. All right. So that's what we're looking at with parabolas. And they can give you these equations in a lot of different ways. Notice the first time I gave you one, it had an h and k of 0. And this time it actually had the numbers. But really the key is however they give you the equation, you have to put it in this general format for a parabola. Okay, and really the only way this format differs from what you're used to, the vertex format, is that they've replaced this A. A is now equal to 1 over 4p. So they don't have to use the new format. Some school systems in Colorado still use this format, which actually is my preference. I prefer that format. And then if you want to figure out what P is, you use this formula down here. A equals 1 over 4P. Okay. Well, if I were to take this equation, the second check mark there, and put it back in the vertex format, then the 12 would go over here as 1/12, right?
Mm-hmm.
So A would be 1/12. Well, if A equals 1 over 4P and A is 1/12, you would discover that P is 3. So there's no magic in the different format. It's just a more direct way to get P. You don't have to deal with this A equals 1 over 4P. I'm pretty sure, in fact, almost 100% sure, that Chatfield uses the 4P formula and not the original, okay? So you're going to have to deal with this format, but realize that it's not really that different than that format there. And in fact, you could always solve for P if they do give you something in vertex format. Let's say I gave you y equals 4 times x squared. What's P?
1.
Yeah, because A, which is 4, equals 1 over 4P. So if I solve that, multiply both sides by P, divide, no. A equals 1 over 4P, which makes 4P equal 1 over A, which makes P be 1 over 4A. It would be 1/16. In other words, it's actually more useful, instead of remembering A equals 1 over 4P, to remember that P equals 1 over 4A.
Okay.
Then whatever you have for A, you can immediately solve for P. All right, now let's talk about something else. That's all detail stuff. You can deal with whichever format they give you. There's something else about parabolas, though. And that is that they can sometimes not be functions. In other words, the parabolas we've dealt with are ones that look like this or ones that look like that. They're what I call vertical parabolas. And these always have the form of y equals some shoot of x squared, okay? Whether it's negative x squared and whether there's numbers there for the vertex and everything, it's always a single y and then x squared, okay? Well, parabolas also come, when you're dealing with conic sections, parabolas come in this flavor. Horizontal parabolas. Notice that horizontal parabolas are not functions. They do not pass the vertical line test. But if I had a horizontal parabola that was right at the vertex, like that, and it opened to the right, I would call that x equal y squared instead of y equal x squared. So the difference between a horizontal parabola and a vertical parabola depends on which variable is squared. Shouldn't be that hard to keep straight because the one you've dealt with for 2 years is y equal x squared. So you know those are the vertical ones. So if it's x equal y squared, that's got to be a horizontal one. And if it's x equal y squared, the standard format is the 4p goes in front of the x, so it's 4p times x minus h equals y minus k squared. There's your general format for a horizontal parabola. And it opens to the right if the y squared term has a positive coefficient. It opens to the left if the y squared term has a negative coefficient. Much like vertical parabolas. Open up if the coefficient of the x squared is positive. They open down if the coefficient of the x squared is negative. So there's two basic formulas, the ones that are the most important, and I'm quite certain that they're going to introduce you to these. And here's what you need to remember. That's for vertical, horizontal. The 4p, the thing to remember is the 4p always goes in front of the linear term. The x is the linear term here. The y is the squared term. And the h always goes with the x, and the k always goes with the y. So those are the two equations. And no matter what equation they give you, if they're asking you to solve for the focus and the directrix, then you have to get it into one of these formats. Okay? They might give you an equation that looks something like the following. They might say x squared plus 4x minus y plus 10 equals 0. And their first question would be, well, what is that? Is that a parabola? Is it a circle? Is it an ellipse? Or is it a hyperbola? Well, we can see that the squared term is x, the linear term is y. It wouldn't be that hard to convert this thing to where it represented that format, a vertical parabola. I could move the y to the other side, it would be positive. I would have to complete the square. I would end up with h or a k somewhere, But I could take this polynomial and put it into the formula for a parabola. Once I've done that, now I can figure out where P is. Whether it's horizontal or vertical, I can figure out where P is. And once you know where P is, you can figure out where the directrix is. And that's the only two things you ever have to really know. Is
Right.
where the vertex is, where P is, where the directrix is. And whether you're dealing with a horizontal or a vertical parabola. That's a good primer.
Right.
That's a good primer on parabolas. Hopefully that'll help you a little bit over the next week. By next Monday, you'll probably be into circles and ellipses. And then we'll need to go over those general format. The most important thing on all of the conic section chapter, memorize those general formats. There's nothing more important than that. That's the way you're going to start every single problem, is by writing the general format of that particular conic section. Now this is just for parabolas. When you get to circles and ellipses, they have a completely different general format that you'll have to memorize also. But there's no getting around it. And if I were you, I would just, if you want to work on something, work on memorizing the formats of your 4 conic sections.
All right.
Okay? All right, Cole. Have a good week. I'll talk to you next Monday.
All right. Sounds good. Talk to you next Monday.